Let us understand port 1 internal structure. Port 1 has 8 terminals, that is P1.0 to P1.7. Each port pin is having such type of internal structure. So here it is written P1.x, that means it can be P1.0 up to P1.7. The internal CPU bus of this particular terminal is connected to D latch or D flip-flop. The Q output of flip-flop is connected to tri-state buffer, and that is used to read data from this latch. This Q bar output of latch is connected to gate terminal of FATE. Here FATE is used as a switch, and that is denoted as M1. One load register is connected to VCC from this FATE terminal. To read data from this pin, read pin is used. Again, there is a tri-state buffer. Then write to latch terminal is used to connect. Write to latch terminal is used as a clock signal for this D flip-flop. So this is general structure of each port pin of port 1. Now let us understand write operation performed on port P terminal. So first we'll see how logic 1 will be written at port terminal. To write logic 1 at port terminal, at internal data bus terminal, we'll send a logic 1. So this logic 1 is connected to D input of this internal latch. Since D input is at logic 1, Q output of latch will be at 1 and Q bar output will be at logic 0. So this 0 will be connected to gate terminal of this FATE switch. Since 0 is connected to its gate terminal, this switch will be turned off. And the output pin terminal P1.x will be connected to VCC through this load resistor L1. So VCC will be connected to P1.x. So P1.x will be at value VCC, that is at logic 1. So we are sending logic 1 on data bus terminal, and that 1 will be available at pin terminal. That means we are able to write logic 1 at pin terminal. Now how 0 is written at port terminal. To write 0, we'll send logic 0 on internal data bus terminal. So 0 is connected to D input of this internal latch. Since D input is at logic 0, Q output will be at logic 0 and Q bar output is at logic 1. Since logic 1 is connected to gate terminal of this FATE, FATE turns on and the current will flow through this FATE. So current will flow through VCC, through load resistor and through this FATE terminal to ground. So this P1.x terminal will be connected to ground through this FATE terminal. So it will get a low reactance path. So P1.x will be at ground terminal, that means it is at value 0. So we have written 0 on data bus and that is written at port terminal P1.x. So this is writing a value 0. Now let us understand the read operation performed at each port terminal. Now for read operation, we have to take one precaution. That is, before performing any read operation, logic 1 should be written at the port terminal. For example, before reading data from port, we have to set, suppose we are using P1.0 port terminal, then before performing read operation, set this bit to 1. That means use instruction set bit P1.0. Or if you are using whole P1 port as a read port, then you have to use this instruction move p1 comma hash 0 ffh. That means all port pins of port p1 are now at logic 1, and then only you can perform a read operation. Now why it is so, that we'll first understand. So here, suppose 0 is placed on this internal data bus. So what will happen? D will be at logic 0. So output Q is at logic 0. Q bar is at logic 1. And this transistor's fate switch will turn on. Since fate switch is on, current will flow through this VCC load resistor and through this fate terminal. Now we want to perform read operation. We have assumed that initially 0 is placed on the data bus, but now we want to perform read operation. So this read latch will be enabled for read operation. We'll send this read signal on this tri-state buffer, and the user has want to read a data 1 or logic 1 is connected to this pin terminal. So what will happen, since this pin is at logic 1, current will also flow through this pin, through this transistor to ground terminal. So there are two currents flowing through this transistor or through this fate switch. One is through this VCC and the other is through this pin terminal, because pin is connected at logic 1. So due to this two currents, large amount of current will flow through this transistor and transistor will get damaged. To avoid this damage of this transistor, when you want to read a data from port pin terminal, this transistor should be kept off. And to keep this transistor off, we have to write logic 1 on this internal data bus. So if you write here 1, D input is at 1, so Q output will be at 1 and Q bar is at 0. So since 0 is connected to gate of this switch, this switch is off, and now we can read a data, that is logic 1, through this P1 terminal, through this tri-state buffer, and that will be placed back on this internal data bus. So we can read this logic 1 from this internal data bus. If logic 0 is written at this pin terminal, or this pin is connected to ground by the input device, then logic 0 will be given to internal data bus through this tri-state buffer. So to avoid damage of this transistor switch or fate switch, first you have to send logic 1 on each port terminal and then only perform a read operation.